Right. Good morning to all of you. In the last class, I have discussed what is assignment problem and the Hungarian method to solve assignment problem. Now, in the class, I am going to solve an assignment problem using Hungarian method. So, write this problem. Solve the following assignment problem. So, write this table. So, there are, for example, jobs. There are 5 jobs A, B, C, D, E, and 5 persons 1, 2, 3, 4, 5. So we have to assign these 5 jobs A, B, C, D, E to these 5 persons 1, 2, 3, 4, 5, so that the total performing cost of all jobs is minimum. So by default, assignment problem is minimization problem. And the entries represent the performing cost. Suppose this entry represent if job A is assigned to first person, the performing cost is 11 units. Okay. So these entries represent performing cost of the job corresponding to person. So I have to find the assignment, that is which job is assigned to which person, so that the total performing cost is minimum. Okay, so clearly this is assignment problem. So we use Hungarian method to solve this problem. So remember, recall the steps involved in the Hungarian method. First, before going to solve, we have to check whether this problem is balanced or unbalanced. Okay, so how do you check balancing the assignment problem? Number of jobs equal number of persons. That means number of rows equal number of columns. So here number of rows 5, number of columns also 5. That is 5 jobs, 5 persons. Okay, so the problem is balanced. Okay, so here observe the difference between unbalanced transportation problem and unbalanced assignment problem. So what is unbalanced transportation problem? The sum of total available amounts not equal sum of total required amounts. Then the assignment, then the transportation problem is unbalanced. Okay, so in the assignment problem, the number of rows not equal number of columns in the given price matrix. Then the assignment problem is unbalanced. Okay, so that is the difference between unbalanced transportation and unbalanced assignment problem. Okay, right, here number of rows equal to number of columns, so the problem is balanced problem, otherwise we have to balance it. Okay, right, so what is the first step? First we find possible assignments for jobs. Okay, so for that we obtain the next matrix by subtracting row minimas from the entries of that row. Okay, right here row minimas here. So first row minima, among first rows, elements in the first row, among these, what is minimum value? 5. So first row minima 5. Second row minima 6. Third row minima 2. Fourth row minima 9. Fifth row minima 6. Okay, so right here row minima values. Now we subtract the row minima values from the entries of that row. So we subtract 5 from first row, 6 from second row, 2 from third row, 9 from fourth row, 6 from fifth row. Okay, so we obtain the next matrix. So what is the meaning of this subtraction? We identify the possible assignments for jobs. That means after subtracting minimum value, we get 0 entries. So those 0 entries represent possible assignments for jobs. Okay, right. Obtain the first matrix by subtracting the minimum of each row from the entries of that row. So the first step in the Hungarian method is obtain the first matrix by subtracting minimum of each row from the entries of that row. Okay, all right. So take the empty matrix like this. Okay, so first row, subtract 5 from first row. Subtract 5 from first row. So 11 minus 5, 6. Right here, 1 place. 10 minus 5, 5. 18 minus 5, 13, 5 minus 5, 0, 9 minus 5, 4. So subtract 5 from first row. Write in first row. Similarly, subtract 6 from second row. So you do the calculation. So for first entry, 14 minus 14 minus 6, 8. 13 minus 6, 7. 12 minus 6, 6. 19 minus 6, 13. 6 minus 6, 0. Similarly, subtract 2 from third row. 5 minus 2, 3. 3 minus 2, 1. 4 minus 2, 2. 2 minus 2, 0. 4 minus 2, 2. Next, subtract 9 from fourth row. 15 minus 9, 6. 18 minus 9, 9. 17 minus 9, 8. 9 minus 9, 0. 12 minus 9, 3. And subtract 6 from fifth row. 10 minus 6, 4. 11 minus 6, 5. 19 minus 6, 13. 6 minus 6, 0. 14 minus 6, 8. Okay, right. So for first job A, what are the possible assignments? This is possible assignment, that is fourth person. For job B, possible assignment, this, fifth person. For job C, possible assignment, third person again. Okay, like that. So these 0 entries represent possible assignments for jobs. Okay, so that is the meaning of first step. Subtracting minimum of each row from the entries of that row. Okay, right. So next step, we find possible assignments for persons. That means we obtain the next matrix from this matrix by subtracting minimum of each column from the entries of that column. So for that, here write first column minimas. Right here, column minimas. So first column minima, 3. So minimum in first column, 3. Second column minima, 1. Third column minima, 2. Fourth column minima, 0. Fifth column minima, 0. So these are minimum values in columns. Okay, right. Obtain the next matrix. Obtain the next matrix by subtracting the minimum of each column from the entries of that column. Okay, right. Take this raw table. So these are column minimas. So first subtract 3 from first column. Subtract 3 from first column. So 6 minus 3, 3. So 8 minus 3, 5. Right, first column. 3 minus 3, 0. 6 minus 3, 3. 4 minus 3, 1. Next, subtract 1 from second column. So 5 minus 1, 4. 7 minus 1, 6. 1 minus 1, 0. 9 minus 1, 8. 5 minus 1, 4. Next, subtract 2 from third column. So 13 minus 2, 11. 6 minus 2, 4. 2 minus 2, 0. 8 minus 2, 6. 13 minus 2, 11. And subtract 0 from fourth column and fifth column. So these two remain same. So 0, 13, 0, 0, 0. Fifth column also remains same. By subtracting 0, the entries remain same. Okay. So this is the second step. Okay. Now, right. So this table, in this table, each row and each column contain at least 1 0. So that means each job has at least one possible assignment. Similarly, each person has at least one possible assignment. Okay, right. Now we identify the assignments, fixed assignments. Okay. So how do we identify? We draw minimum number of lines to cover all these zeros. Okay. So what is the first point? To draw minimum number of lines to cover all these zeros. So first, to consider first row. If first row contain exactly 1 0, so identify first row. In first row there is only 1 0. If first row contains only 1 0, then mark square around that 0 or mark circle around that 0 and draw vertical line. That means we fix that job to corresponding person. That is, the person is fixed to that job. So here the job A is fixed to person 4. Okay, that means fourth person is fixed to job A. So first row contain only 1 0. So we fix that assignment. Suppose first row contain more than 1 0. That means first job has more than one possible assignment. In that case, we are not able to fix the assignment. So skip that first row. Go to second row. Okay, so that is the process. Okay. Right. Draw minimum number of lines. Draw minimum number of lines to cover all the zeros. So here number of lines should be as possible as minimum, as possible as less. If you draw 5 lines, all zeros automatically covered by lines. That is not the way. We have to draw least number of lines to cover the zeros. Okay, right? Observe first row. First row contain only 1 0. Right here, row 1 contain only 1 0. So circle that 0. Circle that 0 and fix the column. So cross off column 4. Okay, so that means this A is fixed to fourth person. That is, fourth person is fixed to job A. So that is the meaning of this. Okay, right. Next, come to second row. So we have to delete this fourth column. Okay, so you have to observe only these 3 entries and the last entry. Okay, so clearly second row also contain only 1 0. So row 2 contains only 1 0. Okay, so this is. So circle that 0 and draw vertical line. So draw vertical line. So that means fifth person is fixed to second job. Next, come to third row. In third row, so you have to delete these 2 columns. You have to observe only these 3 entries. So third row contain more than 1 0. Third row contain more than 1 0. There are 3 zeros. Okay, so skip the third row. Fourth row contain no 0. Fifth row contain also no 0. Okay. Okay, right. So all rows are verified. So now observe whether all zeros are covered by lines or not. So still there are 3 zeros not covered by lines. Okay. Now go to for columns. Go to for columns. Right. Take first column. Observe the first column. The first column contain only 1 0. First column contain only 1 0. That means first person is fixed to third job. First person is fixed to third job. That is, third job is fixed to first person. So we cross off third row. Okay. So that is the meaning of this. Right. Column 1 contains only 1 0. So column 1 contains only 1 0. Circle that 0. So we fix that job. So we fix job C for first person. So we cross off row 3. So cross off row 3. So cross off row 3. Okay, right. So come to second column. Second column has no 0. So you have to skip this row. You have to remove this row. Okay. So in second column there are no zeros. In third column there are no zeros. Okay. So you need not consider last 2 columns. Already last 2 columns are eliminated. Now observe all zeros are covered by lines. There is no 0 entry in these entries. There is no 0 in these entries, in these uncovered entries. These are called as uncovered entries. These are called as uncovered entries. Okay, right. So all zeros are covered by lines. Then we have to go to next step. So observe how many number of lines we have drawn. Only 3 lines. How many number of lines we have done? Only 3 lines. That means we have made only 3 assignments. Actually, we have to make 5 assignments, 5 jobs to 5 persons. So here we made only 3 assignments. So A is assigned to 4th person, B is assigned to 5th person, C is assigned to 1st person. So we have made only 3 assignments. So number of lines drawn not equal number of rows. So assignment is not completed. That means present assignment is not an optimal solution. So assignment is not completed. So we have to improve the solution. So we have to improve the solution. So how to improve the solution? Identify the minimum of uncovered entries. So what are uncovered entries? These 6 are uncovered entries and these 6 are uncovered entries. Among these uncovered entries, take the minimum value. So what is minimum value? 1. So minimum of uncovered entries equal 1. Minimum of uncovered entries equal 1. Right? How do you next? What is the next step? We have to find out new possible assignments. For that, we have to subtract minimum of uncovered entries from uncovered entries. Okay. So minimum of uncovered entries is 1. Subtract 1 from uncovered entries. Subtract 1 from uncovered entries. And add 1 to the entries in the intersection of covered rows and columns. Add 1 to the entries in the intersection of covered rows and columns. Okay. So the entries remain either in covered row or in covered column remain same. For example, in the previous table, so this entry, these 4 entries, these 4 entries remain in covered column only. And these 3 entries also remain in covered row only. Okay. So this entry remains in the intersection of covered column and covered row. So this also in the intersection of covered row and covered column. So for these 2 entries, we add this minimum value, and for uncovered and from uncovered entries, we have to subtract, and these entries and these 3 entries remain same. Okay. Right, next table. So here 3, 4, 11 are uncovered entries. Subtract 1 from these. 3 minus 1, 2, 4 minus 1, 3, 11 minus 1, 10, and 0, 4 remain same. Hence they lie in covered column only. Next, 5, 6, 4. These are uncovered entries. Subtract 5 minus 1, 4, 6 minus 1, 5, 4 minus 1, 3, and 13, 0. These 2 remain in covered column only. They remain same. 13, 0. Next, these 3 entries remain same since they lie in covered row only. So 0, 0, 0. Next, so this is in the intersection of covered column and covered row. So we have to add 1 here. So 0 plus 1, 1. Okay. So that means this possible assignment is removed. This possible assignment is removed. So here 1, that means this is not possible. We have to add 2 plus 1, 3. Okay. Next, 3, 8, 6. These are uncovered entries. Subtract 1. 3 minus 1, 2. 8 minus 1, 7. 6 minus 1, 5. And these 2 remain same. 0, 3. Next, 1, 4, 11. These are uncovered entries. Subtract 1 minus 1, 0. Okay. So here observe, this is new possible assignment. This is new possible assignment. In the previous, it is non-zero. Now it becomes 0. So this is new possible assignment. Next, 4 minus 1, 3. 11 minus 1, 10. These 2 remain same. 8, 0. Okay. So this is the new matrix with the new possible assignments. Okay. Repeat the same process. Now draw minimum number of lines to cover all the zeros. Draw minimum number of lines to cover all the zeros as usual, right? Observe first row. First row contain only 1 0. So row 1 contains only 1 0. Circle that 0 and fix column. So cross off column 4. Cross off column 4. Next, second row also contain only 1 0. Row 2 contains only 1 0. This is only 1 0 in second row. So circle that 0 and fix column. So draw vertical line. Next, row 3 contains 3 zeros. Skip the row 3. Row 4 contains no 0. Skip that. Row 5 contains only 1 0. Row 5 contains only 1 0. So circle that 0 and fix that column. First column, cross off column 1. Okay, right. So now observe whether all zeros are covered by lines or not. So there are zeros not covered by lines. There are 2 zeros not covered by lines. Then go for columns and repeat the same process. Already first column is eliminated. We have to observe only for second and third columns only. In second column, we have only 1 0. In second column, we have only 1 0. So column 2 contains only 1 0. Column 2 contains only 1 0. So circle that 0. That means for column, we have to fix row. That means cross off row 3. Cross off row 3. Okay, right. So now observe the entries. Clearly, there are no zeros here and here. Okay. So in uncovered entries, there is no 0. So that means all zeros are covered by lines. Okay. So observe how many number of lines we have drawn? 4 lines. 1 horizontal line and 3 vertical lines. Okay. So number of lines drawn equal 4. Number of rows 5. Okay. So both are not equal. So number of lines drawn not equal number of rows. That means assignment is not completed. So that means we have made only 4 assignments. In previous step, we have made 3 assignments. Now we have made 4 assignments. Okay, that is A to 4, B to 5, C to 2. We have not made D and E to 1. Okay, so we have made only 4 assignments. That means assignment is not completed. So we have to improve the solution. That means we have to find possible assignments, new possible assignments. For that, we repeat the same process. The minimum of uncovered entries. Okay, so uncovered entries are these 4 and these 4. Among these uncovered entry, minimum of these 8 entries is 3. This is 3, this is 3. Okay, so this is also 3. So minimum of uncovered entries equal 3. As usual, add 3 to the entries in the intersection of covered rows and columns and subtract 3 from the uncovered entries. Subtract 3 from the uncovered entries. Okay, right. So this 2 remains same since it lie in covered column only. Okay, so 2 remains same. Next, this is uncovered entry. Subtract 3 from these 2 entries. 3 minus 3 0, 10 minus 3 7. And these 2 remain same. 0 and 4 remain same. They lie in covered column only. Next, 4 also remains same. It lie in covered column only. And these 2 are uncovered entries. Subtract 5 minus 3 2, 3 minus 3 0. And these 2 remain same. 13 0. Next. Now This entry is in the intersection of covered row and covered column. So we have to add 3 here. 0 plus 3, 3. That means the previous possible assignment is removed here. Okay. Next, these two lie in covered row only. So these two remain same, 0, 0. And these two are in the intersection of covered row and column. Add 3 to these two entries. 1 plus 3, 4. And 3 plus 3, 6. And this remains same, 2. Next, subtract here 3. 7 minus 3, 4. 5 minus 3, 2. And these two remain same, 0, 3. Next, this remains same, 0. So here 3, 10. Subtract 3 from here. 3 minus 3, 0. So this is new possible assignment. So this is new possible assignment. 10 minus 3, 7. Next, these two remain same, 0, 8. So what are new possible assignments here? This is new possible assignment for this and for this. This is new possible assignment and for this. This is. These three are new possible assignments. Okay. So now we have new possible assignments. Again, repeat the same process. Draw minimum number of lines to cover all the zeros. The first, observe first row. First row contain 2 zeros. First row contain 2 zeros. Skip first row. Second row contain 2 zeros. Skip second row. Third row contain 2 zeros. Fourth row contain only 1 zero. Fourth row contain only 1 0. Row 4 contains only 1 0. Row 4 contains only 1 0. Circle that 0 and fix column. So draw vertical line. Draw vertical line. Next, fifth row contain 2 zeros. So skip fifth row. Still there are zeros not covered by lines. So go to columns. Observe first column. First column contain only 1 0. So column 1 contains only 1 0. So circle that 0 and fix column. Sorry, for column fix row. We have to fix row. So cross off row 5. For column, we have to fix row. Okay. Next, second column contain 2 zeros. Skip second column. Third column contain 2 zeros. Skip third column. Still there are zeros not covered by lines. Then again go for rows. First row contain only 1 0. First row contain only 1. You have to remove this column. You have to observe these 3 and this one. So first row contain only 1 0. Sorry. So I have verified only column 3. Next, we have to verify column 5 also. We have to verify column 5. So in column 5, we have only 1 0. In column 5, we have only 1 0. So circle that 0 and fix row. So cross off row 2. Okay. Still there are zeros not covered by lines. Now come to first row. First row contain only 1 0. So row 1 contains only 1 0. Circle that row, circle that 0 and fix column, cross off second column. Next, second row cross, second row already removed. Third row contains only 1 0. So row 3 contains only 1 0. Circle that 0 and fix column. While checking in rows, we have to fix column. While checking columns, we have to fix rows. Okay. Right. Now observe all zeros are covered by lines. So there are no zeros in uncovered entries. So number of lines drawn equal number of. So assignment is completed. So number of lines drawn, 2 horizontal lines and 3 vertical lines. So assignment is completed. The circled zero entries represent assignment. Okay. So optimal assignment is, so this is previous original table. This is original table. So optimal assignment is, so here circle A to 2. You see that is this cell. So A is assigned to 2. Next, second, B is assigned to 5. This is B is assigned to 5. Next, C is assigned to 3. C is assigned to 3. Next, D is assigned to 4. D is assigned to 4. Next, E is assigned to 1. E is assigned to 1. So this is optimal assignment. Assignment of 5 jobs to 5 persons. So job A is assigned to second person, job B is assigned to fifth person, job C is assigned to third person, job D assigned to fourth person, job E assigned to first person. So this is the optimal assignment. Now performing cost, total performing cost is minimum assignment cost equal sum of all these entries. So 10 plus 6 plus 4 plus 9 plus 10. Sum of the corresponding entries from the original matrix. You have to take the entries from the original matrix. Okay. So total 39. So with this minimum performing cost, we can assign the jobs to persons. So this is the optimal assignment. Okay. So this is the way to solve an assignment problem.